Welcome to this video on distinguishing between a point and a slope. Let's begin. Suppose you are given the information parentheses 1, comma 2, close parentheses, and I tell you this is either a point or a slope. Which one is it? So pause this video, think about which one it is, and then unpause it to see if you are correct. So the correct answer is that this is a point or an ordered pair in space. Remember, we write ordered pairs as x, comma, y. So what that means is if I have a Cartesian plane, let's say, right, I could graph this point by, if it's 1, comma 2, I go over 1 unit and then I would go up 2 units. Okay, so that point right there is the point 1, comma 2. Okay, so let's compare 1, comma 2, a point in space, to 1/2. Okay, so 1/2 can mean a lot of different things in different contexts, but let's pretend I tell you, okay, 1/2 is either a point or a slope. Which one is it, right? Well, I know that it is not a point. It can't be a point, right? Because we write points or ordered pairs as x, comma, y. It's not written in that form. Therefore, it must be a slope. So remember some of our definitions of slope, right? One definition is it's the rise over the run. Another definition is it's the change in y over the change in x. So how could I graph a slope of 1/2? Well, the truth is that I can't really graph it because I don't know where it is located in space. What I do know is that when I go to graph the slope, I would go up 1 unit and over 2, up 1 over 2, up 1 over 2, right? And that would sort of form a bit of a stair step, if you will, right? And that would give me my slope of the line. However, the problem is I have no idea where in space this line is pinned down. So I don't really have enough information to graph the line. Okay? So the common mistake that I see all the time is that I will ask students to find the slope of the line, right? So I'll give them an equation. So let's say I give you the graph of this line here, and I ask you to find the slope, right? So you can pick any 2 points. I'm going to pick this point and this point. Doesn't really matter, right? And you figure out what is the rise and what is the run. Right? So remember, my slope is the rise over run, or you can think of it, you can think of it as the change in y over the change in x, right? So to get from point A to point B, I would have to go down 1 unit, which is negative, so my delta y would be -1, and then I would have to go over to the right 2 units, which is a positive direction, so my slope would be -1/2. Okay, so instead of writing it like that, a lot of my students will instead write -1, comma 2 in parentheses. So let's think about what we actually mean if we write the point -1, comma 2. Okay, -1, comma 2 actually means that I would start at the origin and I would go to the left 1 and down 2. So -1, 2 is actually not a slope at all. It's the ordered pair right here associated with this point. So hopefully we can all agree that this point over here has absolutely nothing to do with the line that we just graphed. Okay, so I can understand how it feels like a point and a slope should be the same thing, or they should be similar, or they should be able to be expressed in similar ways, right? Because you're still moving in an x direction and a y direction. Okay, but they're actually very different. So let's make a table of values to really just hone in the difference between a point and a slope. Okay, so first of all, the most important thing is that a point is a measure of position. Okay, so a point is given as an ordered pair, as we have previously mentioned. Okay, and it's going to look like x, comma, y, right? So again, for example, it could be 1, comma 2, or it could be -3, comma -5. Right? And this tells me to, remember when I'm plotting an ordered pair, I always start at 0, 0. I start at the origin, right? This tells me how many units to move left or right, and then this number tells me how many units to move up or down. Okay? So another difference between the point and the slope is with a point, I always start at the origin. I start at 0, 0. Okay? Unlike a point, the slope is a measure of direction. Okay, and we write it as a fraction, right? So remember, we can say that it is the rise over the run, right? Or it's the change in y over the change in x, right? So it's just one number over another number, right? Or we could have a slope of -3/5, or we could have a slope of 7/8, right? But again, when you write the slope, you must write it as a fraction, Okay, if you write a slope as something that looks like this or like this, okay, you're going to lose points because, again, notation is very precise in mathematics. And when math people write something like this, they are talking about a point. When they write something like this, they're talking about a slope. So what if we take the point and the slope, those two pieces of information, and we put them together? That's when we get the equation of a line. So the equation of a line gives information about both the position of a line in space and its direction, right? Meaning, is the slope positive, negative, 0, or undefined? Okay? So the equation has a what? A blank and a blank in space. So it has a direction, meaning a slope, right? So it has a direction or slope, and it also has a location, or you could say it has a position in space. Okay? And one of the ways to write an equation of a line, there are many, many different ways, right? But one way is to use the slope-intercept form, right? So if you happen to have an equation in slope-intercept form, right, then we know that our m is our slope, right? So that should look like either a whole number or a fraction, right? We should not have an ordered pair there for our slope. We have just a rational number, right? And then we have our b value, which is the y value of the y-intercept. Okay, so again, this part of the equation is giving us the direction, if you will, right? The slope is telling us, does it go up, down, left, or right, and what what are the numbers associated with that, right? And then the y-intercept is, right, telling us where it is pinned down in space.